This is Sin World. Wait, sorry. This is Sine of the World. We can apply a mathematical function to the globe. And notice there's a lot of repetition. There are a bunch of different copies of Turtle Island. This may seem weird, but the sine function repeats in the normal numbers, so it makes sense that it would repeat on the globe too. We also see repetition on cos world, and we also see repetition on tan world, and we also see repetition on many other worlds. But I still haven't explained what these even mean. In this video, we'll take a look at my logo, and we'll learn how to apply a function to the globe and explore a bunch of cool examples. Let's start by finding world 2. In my last video, I showed how we can map from the globe to the imaginary numbers. For example, Perth gets mapped to a half plus a quarter I. And now that we have a number, we can multiply it by 2. Then pan back to the globe to get Perth 2, which is in Malaysia. And it's pink on the map, so let's color Perth pink. If we do this with every point on the globe, we get world 2. It looks weird. The northern hemisphere grew, while the southern hemisphere shrank. This is because the small numbers are around Antarctica, while the big numbers are around Uncle Arctica. Multiplying by 2 makes every number bigger, so everything moved towards Uncle Arctica. We see the opposite with half world. Everything got cut in half, becoming smaller, so they moved towards Antarctica. We see more of the southern hemisphere. And for some extreme examples, here are world 10 and 10th world. These are fun, but they're quite uniform. We get a more lopsided result with world plus 1. Turtle Island is tiny, while Asia is huge. This side is skewed north because these are the positive numbers. A positive plus 1 is a bigger positive. But then this side skews south because these are the negative numbers. Negative plus 1 is a smaller negative. And here, small means close to 0. So negative oi boy o is small, while negative zobi zob zob is big. It's big in the negative direction. This means that a negative minus 1 is a bigger negative. So in world minus 1, the negative side, Turtle Island, grows, while the positive side, Asia, shrinks. We could also try world minus 2 or world plus I. Adding any constant will deform the world in some direction. And speaking of powers, here is the world squared. It looks kind of normal, and that's because uncle numbers get more uncle-y when they're squared, while aunt numbers get more aunty. The north and south grow evenly, pushing everything else towards the equator. But if we take a different perspective, we see that there's 2 of everything. The world is duplicated. Well, there's still just one Antarctica, but it has 2 of its arm thing. I don't know the official name. Do you? This duplication happens because negative 1 squared equals 1, meaning that negative world squared equals world squared. And the negative world is just world plus 12 hours. These are rotated versions of each other. And since they have the same square, that square must be a rotated version of itself. It must have duplicates. This idea continues with world to the thirst, and world to the ford, and world to the fist. We get more and more mini copies around the equator, while aunt and uncle take over the poles. In Admiral, there are n copies of everything when we use x to the nth. And we can further admiralize. There are also n copies with x to the nth plus 1, or x to the nth plus x, or x to the nth plus x to the 2th. The number of copies is the highest power. With this polynomial, the highest power is 4, so we can see 4 copies of each continent. And we can factor the polynomial to find its roots, the values that go to 0. And 0 is the middle of Antarctica, so we see an Antarctica at 2, at I, at negative 2. Given a polynomial, we can find its roots. But we can also go backwards. We can pick certain roots and use them to make a polynomial. And to make this more fun, we can start by picking cities, convert them into roots, and then use those to make a polynomial. Here, the roots are far apart: Berlin, Toronto, Jakarta City, and Seoul. There are 4 Antarcticas spread around the globe. And then here, the roots are all close together. Springfield, 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 and Cedar Rapids. Because they're all close, we don't get 5 separate Antarcticas. They merged into a super Antarctica that has 5 arm things. The polynomial for these roots is x minus Springfield times x minus Springfield times x minus Springfield times x minus Springfield times x minus... Ow! Oh! Cedar Rapids! These cities are roots because if we plug one of them in, such as Springfield, then this term is Springfield minus Springfield, which cancels to 0. And so the whole thing multiplies out to 0. But what if we take this polynomial and divide one of the terms, such as the Springfield one? Now if we plug in Springfield, we'll be dividing by 0, which is impossible. So Springfield is no longer a root. Now it's a hole. And it makes a hole in the map. There's a mini world inside of the super Antarctica. At Springfield, we divide by 0. So near Springfield, we divide by tiny numbers, such as ubo subo boo. Dividing by tiny numbers results in huge numbers, which are near the heart of the uncle. And as the input gets very near Springfield, the output gets very near Uncle Heart. And so we can reasonably say that Springfield goes to Uncle Heart. So on the map, we have an uncle surrounded by 4 ants, hence the hole in the super Antarctica. And in Admiral, we can say that dividing by 0 equals Uncle Heart. If we do this, then every rational function is continuous and differentiable. A Rashi-func is a polynomial divided by a polynomial. And we can factor each polynomial to get the roots on top and the holes on the bottom. So on the map, we see ants at Jakarta and Warsaw, and uncles at Hyderabad, Cedar Rapids, and Busp. And we can create a new Rashi-func by picking any set of aunts and uncles. If we pick an aunt and uncle far apart, such as Sao Paulo and Vladivostok, then the globe looks tilted, but it's still pretty normal. But if we make them close together, like Springfield and Springfield, then the world is mostly ocean. Everything is between the aunt and uncle, which are close, so the whole globe is squished together. And watch what happens if we make Springfield a double uncle. This means we square the bottom term in the Rashi-func. What if we make a double aunt by squaring the top term? Or a double aunt and a quadruple uncle? Or a quintuple aunt and a triple uncle? And there's a lot more we can explore with these Rashi-funcs. Thanks to the recent supporters of the channel.